Hi guys, welcome to the second part of this org mode support series of videos. Now I ended up having to, after the first video, I ended up having to not record very much because as it turns out, well, predictably I guess, the work was actually quite complicated. Really wasn't too hard, but it just required concentration really. And I think a lot of this work will, so I'm afraid it might be a bit sparse on the recording front, I think. So what we've done since the last video was we completed the org mode model, which was at the start of the video was fairly similar to this. There's a few mop-up exercises here, but largely it stayed as it was modeled. But the difficulties really were on the classes that had to do the parsing and sort of the reading. So what we've done is we created a number of tests. And this is actually the final bit, so let's just go back one into the org tests. Sort of in a TDD sort of fashion, we created a number of documents of increasing complexity, as you can see here, different kinds of org mode documents, and created tests for each of these documents and validated that the tree that came out of it, or the org document that resulted out of it, actually was what we expected. And so it took us a while to go through all of these different permutations, but it kind of seems to have worked. And then in the end what we did is just for good measure, we created some tests that read all of the existing org models. Now we don't do a lot of checks here, to be fair, but we just basically wanted to see if it could read the model or not. The reason why we're not really bothering with too much in-depth checks is because we will at some point plug this into the plumbing, and then the code generation itself becomes a test. So if you don't generate the expected code, then clearly something has gone wrong. So these tests are just basically proving that we're not going to blow up when we try to read the models. Not much more than that. So the purpose of this video then is going to be to do the integration of the org mode model over with the codec model. So what we've done is we have this org representation here, and we have the codec representation here, and we just need to translate or transform between the two. This may also get a bit hairy, so I'm not really sure how much we can record of this, so let's just give it a go. But we probably will at some point during this video just call it a day and then continue with quite a lot of concentration. So if I have a quick look at the tests, I think we have a test. Here we are, this guy here, and at present, of course, it's blowing up somewhere in the guts of Dogen, as you'd expect. So I'll look up to the log files. Yeah, you can see here we're just blowing up because we don't have a configuration point, which is kind of predictable given that we're actually not doing any work at all. So org artifact to model. What we probably should do is just get something like a JSON artifact to model and use that as our baseline. And you see what we're doing here. We are now we can't precisely copy the JSON model because basically there's two ways of representing data sort of for the Dogen codecs. They either use a flat approach with some kind of linkage in which all elements are at the same level, and then there's some kind of ID that we use to link containments, which is what JSON and in Dia do. Or there is actually some kind of topology like org mode has. So there's a tree and there's depth and there's recursion. Now org mode is actually the first time we've encountered proper depth in a tree-like structure. So it won't follow the pattern of any of the codecs that we had so far. So, and also we don't really require some streaming because we can convert interestingly enough, we're starting with an artifact. So I'm just trying to get my head around this. We haven't seen this code for a week or so. This is what I mean about having to load and unload state from your memory. So there's the notion of an artifact of some kind, and a codec name and a content, and we are already taking whatever is in that artifact and converting it to an org document, and then well, I guess then the problem is we need to figure out we need to extract bits of this org document and create the modeling elements, right? We don't seem to be able to distinguish between org elements at the codec level, which is what you'd expect. But one of the problems we have is that at present we have containment represented by graphs. So this is interesting, isn't it? Because as we're looping through the... So let's just try to make this a bit more concrete. If I go up to the model... interesting, we don't seem to have a model. Okay, let's just open up a new area. We must have some org model in memory somewhere. No, we don't actually. Okay, let's just do a quick... jump over. I think we restarted Emacs at some point, and that's why our session is looking a bit strange. Let's just take something like the text model, which is one of our favorites. Right, so let's imagine we got this model and we're kind of going through it. The first thing I guess we need to do is to locate the properties of the model. So that's easy enough. And then every single headline, for now we're just going to assume that every single headline indicates the notion of an element. But the problem is, because we are not a flat model, we need a way to keep track of containment. And one simple way is to have a function that recurses, that basically says, what is your parent's name? And it's concatenating its parents with itself, so that by the time you find an element, the name will be the concatenation of all the names up to now, and that would be sufficient for Dogen to know the structure of the types. So that's all making a lot of sense. So let's just start with something really simple, such as create configuration, I guess. We must have some configuration. We don't seem to have... Right, so we have a notion of read KVPs in JSON. Let's have a look at what we do with that. We have read tag values and we have read KVPs. Interesting. See, as you can see here, we can clearly already see there's three things here that don't match. So for starters, we don't really have that function. Then the order of this is not correct. These are the sort of things that annoy me profoundly. So it should have been read stereotypes first. It's the whole refactoring that happened here, and we must have lost track of what we're doing. Then redocumentation and then read tag values. Okay. Right, so that looks a bit more sensible. Now we seem to read tagged values. We don't seem to have configuration, so presumably the codec model doesn't have variability. Oh, it does have variability, so that's interesting. Why don't we have a configuration, I wonder? Or put it differently, why do we even bother including the variability model if we're not using it? So let's try something like that. Let's just see if this is not some kind of artifact from the past. See if I try to generate. First, let's make sure you're from the latest code generator. And then what we'll do is we will attempt to co-generate all the models. Bang. So we do use configuration somewhere, fine. Annoyingly, this right, so let's try to see if we can figure out who's using configuration. There we are. Configurable. So elements are configurable. That being the case, the question one has to ask is, why do we have the tag values as well as configuration? Presumably the tag values are just the input for configuration. Seems like something historical happened here. There's no mention of the word configuration here. Although, to be fair, we have to be slightly careful that we are not assuming anything here, because look, there is a configuration transform. Okay, so what's probably happens is we start off with a raw form of configuration, which is tagged values, and then at some point we have a transform that converts that into configuration. But the interface with the the codec, the input model, is just the tagged values. So we don't really have to worry about the configuration itself. So all we need to do is to extract the tag value. So the first thing we need to do is to go back to that JSON and then to say read tagged values, this guy here. So let's try something very similar to this, if I'm honest. In fact, we might even be lazy and just copy the read tag values from here. But the difference will be, of course, that in this particular case, we want something like org types entities. The tagged value will come from a property, presumably. So drawer. Right, so let's say we take org entities drawer, and let's say we create a tagged value from it. That sounds vaguely sensible. And yeah, I think that's a really good start. I mean, we are kind of trying to warm up at the moment, so it seems easy enough to get us going. Now, that's probably alright. So we want to return something like this. And then, right, so the first thing we'd expect to see is, if you're an org model, we expect to see one and only one drawer, right? So the first thing we need to validate is org models are expected to have exactly one drawer type one property drawer. So now we will leave the other guy to do the checks, make sure it's a property drawer. We're not going to worry about that. But what we're going to say is D. So D is for document. So let's just call doc, I think, for document. And if we say doc.drawers.size, must be exactly 1. So if it is not 1, we have a problem. Now I'm not sure what kind of exceptions we got here, but a transformation error would do, I guess. Put the arg at the top. Right, so if we just throw, as you can imagine, we're going to expect a very, very structured org mode document. This is not flexible. This is not really a generic parser for org. It's going to do just one thing and one thing only. Unexpected number of drawers. Right, so let's just start with this. Something like this, right? And I guess we probably could just do something like and perhaps suppose like scorecast, I guess. Okay, so as you can see here, we are not doing anything particularly clever, and this is the gist of all this work. Really, it's very, very simplistic, I guess you could say. Now this guy here is basically going to do some more checks, which are going to be similar. So if d dot type is different from org entities drawer type property drawer, and I think we're gonna probably just use this guy. So if it's not a property drawer, well, an expected drawer type really. So as you can see here, you're probably going to be like, well, this is very, very strict. And yep, that's exactly the point. We are not really going to support the wealth of permutations and combinations that org gives you. We are just going to go for very, very simplistic kind of support. So here we just want something like some kind of drawer type IO, I guess. And right, so very, very simplistic, right? So this guy is going to read the drawer type, and then we will create our model. Presumably this guy will go first, and then we could do something such as right, so this just basically gives us the drawers for the first element. Very, very simple. So ensure that's the case and read its contents. Right, so there we are. We just read the properties drawer. Now, one could also argue, actually, that pretty much everything will have exactly this condition. So actually, we're going to just change this slightly. Well, this looks good. We want to change this slightly and say something a bit more like, let's just take this definition of drawers. I mean, there's nothing wrong with what we just did. However, we probably will end up repeating this code all over the place. So instead of dealing with the drawers like that, we're going to deal with them slightly differently. And we will basically do the work that we're doing here in the method, because I think, as I said, there's an expectation of a shape. So we can just assume that all these elements are going to have the same shape. So what we'll do instead is this. We'll say, okay, your drawers must have exactly 1 in the size. That's cool. And then we will obtain the drawer from the drawers dot front, and then we will do whatever it does, and then we will just say, well, for that document, just give us the drawers. And as you can see, the reason why we're doing this is purely because this is going to make our life slightly easier when it comes to the elements. You can just sort of imagine what's going to happen in 5 seconds time and just cater for that now. Right, so there we are. We have a drawer, and now clearly we're going to have to do whatever it is, drawer contents. So drawer presumably the contents. So now we're looping through the contents. So for each content, presumably we'll have to create a tagged value, and then the tagged value is going to have. Let's make our life easier a little bit. Not too much, just a little. Right, so there we are. Get the tab values, the tagged value dot key, presumably. The tag is going to be the drawer contents dot key, and the tagged value dot value is going to be the drawer contents dot value. It's something like this, right? And then you push that into R, and then you return R. So I can hear some noises, so if you bear with me 1 second. Just the usual chaos, make sure we're recording, we are. Right, so clearly pushing R into R is not the best of ideas. Alright, so at this point in time, we should vaguely be reading the tagged values. So let's see what happens to our test. We expect, well, to be honest, we don't have to run every single test, but right, we have a problem. Never seen this error before, if I'm honest. Never a good thing. Okay, don't know what we've done there, but clearly we've done something very silly. I don't see why this is so wrong. If I'm honest. Okay, this is what I meant about needing a bit of concentration. This is really, really silly here. So we obtained the drawer size. We checked the size to make sure it's 1 precisely. We have some kind of basic string with some text. We want to concatenate that text with a number. We cast that number to a string, we add the two together, and we throw. Now that to me looks perfectly reasonable. Not to the compiler though. Sadly the compiler is always right, so I'm sure we're doing something very, very silly. Are we sure we're including boost through exception? We are. Let's just fix the order slightly. We are definitely including we included the I/O for the drawer type. Okay, so I'm just gonna, just for a laugh, just make sure we comment out all these bits here to see if that gives us compilation, and it does. And now, okay, it's failing somewhere else, but that's fine. Oh, I know exactly what's going on here. Sorry, apologies. We seem to have made a very bad copy and paste error. What we really meant to do is something like this. Alright, that makes a bit more sense. And here I hope you can see precisely why it is that we don't try to record too much around here. Because as you can imagine, this is such a basic error. It sounds quite innocent really, but if you imagine over a period of 8 hours doing errors like this, and it takes you a little while to fix each error, you will end up struggling. Now the second thing we probably want to do is we want to check. Let's go back to our models. Okay, somehow we lost our... Oh, we didn't really rename it properly. Right, so the second thing we want to check is we expect pretty much every single property to have a key and a value. I think this is almost by definition, so let's just double check that as well. Let's put a comment here so we remember. So what we tend to do around here is we tend to throw on all of our assumptions. It's a bit excessive to be honest, but it has actually helped us in a lot of cases really. So if dc.key.empty or dc.value.empty, so we'll just complain about this property. And then what we'll do is we will, for the logging, we'll just add a bit more. And we'll just basically say what the key is. And what the value is. Just purely because it makes our life easier. I should really create a macro for this, keep forgetting. Right, so that would give us some basic check, make sure the property has both the key and the value. So by the time we get here, we know for sure we got a key and a value. So let's just see if this throws. Hopefully not, but possible. Okay, so it does throw. Now let's go up to our logs. Right, excellent. So we found a first problem. So for whatever reason we have a property that was not split correctly. Now, I see the problem. Okay, so the problem and the reason why this was not picked up by our tests is that we did not account for the dots in the key name. So the tests that we've got don't have a dot in the key name. So if I just go back to our tests, you will see let's have a quick look at our drawer tests. Yeah, as you can see here, we have underscores but not dots. Let's just double check this is valid syntax according to the org spec. Let's look for property drawers. Contents, node properties. Right, name can contain any non-white space character but cannot end with a plus sign. Okay, that's fine. So we can have dots in it, so that's okay. However, the parsing that we've got at the moment for keys, let's try to get ourselves back to the document. Okay, 1 second. Usual chaos going on around here. Always requires a stop and start sort of effort. Right, so the problem we have at the moment, our parser was a little bit naive, but I think that's alright. Let's just get Emacs back to sensible state. Now we have a parser here. Not much of a parser really, but simple parser I guess you could say. Right, this guy here has a regex. Let's have a quick look at what we think the key should be doing. Make sure we're recording. Right, so let's think for a second what's going on here. So we are trying to record. Okay, so this is parsing. Right, there's the parsing of the drawer content. Okay, so this is the problem. The drawer content regex assumes we have a word. Right, as you can imagine, dots is not part of the word. So what we'll have to do then, to be fair, we don't really want this to be completely flexible, because our keys are all very, well, they follow a very straightforward form. So really all we expect is some kind of alpha character plus the dot and perhaps an underscore, I think. I can't see any examples of a use of an underscore, but I suspect we may have underscores in some cases, right? So let's just do a quick bit of surgery here. Let's just take this guy instead of the W, and then let's add the dot as well as the underscore, just for good measure. And now let's run the test. I mean, of course, if you were doing this properly, you would actually now go back to the tests, create a key with a dot in it, and check that. But we take a bit of a kind of a laissez-faire approach to testing around here, which is a bit funny, I guess. which is, I mean, if something's already going to be tested somewhere else, then we don't really bother putting tests everywhere, because otherwise we never get anywhere really. Right, so that didn't seem to have helped. Oh, did we forget the plus by any chance? We did not. So we're saying is, if the drawer content regex as any characters either A to Z or capital A to capital Z, or the dot or the underscore, that should match. I'm afraid that should have matched. So we just have to look at this very carefully, because I think we're missing something very obvious here. Ah, okay. Right, what exactly is the escape doing here, I wonder? Not sure why. Ah, okay, I think we didn't quite handle everything here correctly. So as you can imagine, /w is part of the regex, and that's why it was double escape. So I think there was just basically a couple of slashes there too many. Let's have a quick look at what the log file now says. Aha, okay, so that seems to have done something. Okay. Okay, that's excellent. And of course we're not going to find .org, so wow, believe it or not, that actually seems to have done the trick. So we are now reading the attributes for the model, so that's really good. Not entirely sure what the next step should be. We could now add support. So if you try to understand what this error is saying, it's basically saying that it managed to read the references. It found the reference to a model called Dogen profiles. So if I just go back to our models, you'd see. In fact, there's one thing we're probably not doing correctly is just go up to tests and let's make sure we are looking at the right. Let's make sure we're looking at the right model. So this is Dogen org. Okay, so in our usual circular way, we are looking at the org model for the org model. So there we are. The org model for the org model is this guy here. And now look, it's actually reading all of this quite correctly. And then it is trying to load the references, and then it's failing to load the references. Now the reason why it's failing to load the references is actually quite trivial, actually, funnily enough. So let's just fix that. It's merely because the references resolver is not clever enough to look for org mod files, so we probably here we go. So we need to tell it about the org extension. And I suspect. Now let's look at who's calling the references resolver. Model set production chain. Right, somebody must be creating. Here we are. So if we just basically say to this guy here, please look for org. Perhaps this would now load the org model. This is, as you can see here, it's all a bit hard-coded, but we always start with some hard coding. Ah, okay. Wow, this is a bit unexpected. I think our test, okay, the reason why this test is passed, I mean, really didn't expect that test to pass. The thing why our test passed, the reason why, we must be running the wrong test, I think. No, we are running the exertion test. Okay, that's really unexpected. We wouldn't expect that test to pass at all. Why did that test pass? It's really strange. I mean, most certainly would not expect the test to pass, given that we're not parsing 99.9% of the model. There's a bug somewhere. Let's have a quick look at what the code generator generated. Let's find a little area here. So let's go for 20. Let's see. I'm running out of names, but let's call it outputs. So there should be a directory here by products. And presumably dogen.org. Oh, interestingly enough, we have a dogen.org .dia, but not a dogen.org.org. Okay, so that's already a bit of a red flag. That is very strange. So inputs. I wonder if there's an error in the way we named the model. So the model should be named dogen.org.org. Okay. Right, so now, okay, so this requires quite a lot of concentration, right? So there is a model called Dogen, and that model has got an extension. That extension is .org, .dia, .json, whatever that is. So the model we're rendering at the moment is the Dogen model, which is a very simple model. So if we then have a quick look at that model, which is this guy here. Well, let's try to understand why. The Dogen model, which is the API model really, this is the top level API for Dogen. Simple model, I guess, but it still has a lot of stuff, so you'd expect to be generating a lot of stuff. So therefore, there should be a massive diff. Let's just double check that the log files don't show anything particularly strange. Oh, okay, that's interesting. So somehow, because we generated absolutely nothing, there was nothing to diff. Oh, this is actually a very interesting bug, funnily enough. So I think what happened is we generated absolutely nothing. For starters, we seem to have loaded a lot of elements. which seems to imply, well, actually, okay, that's fine, because I think all that's happening there is we're loading a whole lot of elements from JSON. These are the JSON models, so that's fine. This is basically just the platform definition models, and these are loading, so that's fine, that's not a problem. Then, of course, most of these things are not going to generate artifacts. Which is good. There's quite a lot of noise going on from downstairs. Yep. Right, we're back once more. Sorry for the interruption. Yeah, so I think what we found is we found a very interesting bug. And the bug is, if there are no files found, in other words, if we didn't generate anything at all, it does not seem like we're clever enough to say, oh look, there's a massive difference. One's got a load of files, the other one hasn't got any files. Seems like our diff you can see here, there are no directories to analyze. Let's have a quick look at this file status collector. Try to understand why it thinks that there are no directories to analyze. Right, so files by status. But we have to be careful here. We don't really want to look at some internal so let's just be careful here. So what's happening at the moment, believe it or not, is it's just a comedy of errors here, I think. Clearly we're not going to generate any diffs if there are no files. Because we've got nothing to diff. So if we literally get nothing at all, then our logic at present fails. It goes through one massive black hole. What we should really do is we should now say, oh look, there is a whole lot of files. But I think this is unfortunately not going to be an easy thing to fix. So let's just try to grab a couple of lines from here. We're not really going to be able to fix this sort of video, I don't think. So let's just say something like error, no, empty model generation produces no diffs. Okay, not quite sure what we've done there. Oh, there we are. So at present, if we do not generate any files at all, the diffing system breaks down. This is because we always diff the generated files against the expected files. In fact, it's not even quite correct, is it? What do? We diff. No, against the actual files, I think. But if there are no generated files, then we have nothing to diff. Logs. We need to look at the actual files and report all of those that exist have no match in the generated files collection. Right, so we're going to have to deal with this a bit later. First, because it's not a very important bug, because it only happens under very strange conditions. And second, because I don't think it's going to be trivial. We just have to really put our head back into this stuff that we haven't done for a long, long time. So I think we'll just leave that at that. We'll leave it as a bug. We'll have to look at the bug later. So let's just not worry about that for a second, because as soon as we start generating elements, we're going to start generating some code, and then we're going to start having errors, so that's fine. After that little diversion, what we should do now is we should just go back to where we were, which is this guy here, right? So okay, at present now we are reading the properties for the org model, which is good, and then we now need to do is start reading some elements. I think this will not be too complicated, so what we'll do now is we'll basically say for each headline, which is this guy here, so for each headline, just remember the parent name, so we're gonna have to recurse. So we need something like this. Reads elements recursively. And that will be something like this. Static std list of codec. We are in codec, I guess. So entities, elements. And these are not pointers, I don't think. These are just elements, so that's fine. So if we could just read an element, and if I could just return, so we need two things here: const string by reference parent name, and then if you could say org entities headline. So supply us with the headline, and what we're going to do is we will let's organize our right. So as you can see here, this guy is going to basically say create an element given what you've got. However, it's not quite that straightforward, because we need to distinguish between the elements which are properties. I think we found a problem. So at the moment everything is modeled as a headline in dia and org. However, somehow we need to be able to tell the difference between an attribute, as you can see here we have a notion of an attribute, and the regular elements. And at present we don't really have a simple way of doing that. However, there is one thing we can do very simply. We could create a tag for these things. So the tag would be something like MASD elements. And MASD attribute, presumably. So let's have a look at configuration. Configuration, this guy here, model processing, will be this guy here, so there will be a MASD attribute. And that is probably the smallest amount of information we can supply in order for this to work. I mean, of course, I could be a bit of a cheater and then look for things like a type. If you have a type, it must be an attribute. But I think that is going to unravel at some point if we do that. Because, for example, say you're an enumeration, and an enumeration, like for example tracing level. Well, we do have a stereotype, to be fair. So it's not clear that we always be able to infer. I think sometimes we just have to take the hit and actually allow this to take place. But however, I think we're going to end up with some kind of problem here, because this is a bit of a nightmare to line up. I was trying to avoid very hard not to use tags, because tags in org mode seem to have some kind of weird logic around how they get lined up. I think okay, it seems like we seem to place the last bit of the element on column 76 for some reason. So we could create some kind of logic for that. We could just basically say place these things at the end of the string. For now, actually, we're not going to start with all that cleverness. We're just going to start with something really simple. Right, so okay, so what is the simplest thing we can do here in order to determine whether something is an element or an attribute? I mean, of course, you'd probably say, well, how do you know it's a package? But actually, it doesn't really matter. If it's a package, we just consider that to be an element. So that's fine. We will just call that MASD element. Okay, cool. So let's just go with that then. And as a first go, we will just generate these things in a random place, because we also, there's some other work coming through, so we're not going to really be able to do that right now. So so let's just say in our codec, we have a codec somewhere. Org model to org artifact, perhaps. Yeah, here we go. So this guy here, which is one big hack, is already doing, as you can see, copy and paste bugs here. Right, so outputting some of the properties, parent to child. So all we need is for where we are inserting elements, inserting attributes. There we go. So so we have something like element tag and an attribute tag. Okay. And then what we're going to do is we're going to say something like right, so up to here we've got pretty much everything, just don't have a way of calculating the spacings. So perhaps what we can do is let's just create a function for this. Let's say there's a function here called, this is all very kind of simplistic really. And then if you say in that function something like, so give us a level. Give us a title, I guess. And then give us a tag, and we know for sure there's only one, so right, so this will do something really simple, and it will be just after tidy up string, whatever that is. Okay, I don't even think we are using tidy up. There's a lot of messiness around this code base at the moment. We just haven't got enough hours in the day to do a good job at keeping this all tidy. And it really is annoying when you're coding on a very untidy code base. Okay, cool. So now then, let's just say we do something like take this guy here. Let's say we do something such as std string streams. Actually, probably OS is a slightly more sensible name. And then OS for the stars, and then of the title plus the space. And if we compute something such as the size, which would be something such as const unsigned, no, let's go const int tag spaces. Now the tag spaces is going to be basically the number of stars plus number of stars plus 1 plus the title. Okay, so that gives us how much we've consumed already. Now we know we want to end up in 76, so we subtract 76 to that. Okay, so what are we trying to say? We're trying to say we would like to end at 76. In fact, maybe we're doing it the wrong way around. We should probably start with 76. Whatever, was it 76? I'm pretty sure it was 76 that I told us a second ago. 76, right? So we start off at 76, say, and then we say how large is the tag? Okay, so, and then of that we subtract the size of everything else, and roughly I think this will give us the number of spaces. So now if we just basically say give us auto here. Okay, excellent. So this basically is more or less, roughly this is going to be the number of spaces. So then we could say, let's call this tag space count, and then let's just say that there's a const string tag spaces, which is in effect this guy, comma the space. And so then we can just basically say, okay, I mean, you probably not going to be exactly correct what we're doing here, but I think you get the gist of it. Now we don't really want to end the line after the title, and then we just return that. Okay, so it's not particularly spectacular, but you see the gist of it, right? And so now we just have to locate the attributes, and then we just have to supply the level and the title, and then something such as the element tag. Well, actually, in this particular case, what I really meant is the attribute tag. And then we can just put the headline into the stream. Okay. And if we just do the exact same thing for the elements, minus a few small changes. Right, now if we were to rebuild this code generator, and then if we were to generate all of our org models, actually we are really recording this, we are, about an hour into it. Okay, so now what we'd expect to see if I go up to Git is a whole load of org models changed. I mean, this is not going to be absolutely brilliant. As you can see here, we already have a few problems, so we'll debug these problems, but it's roughly doing what we want. Not exactly, but roughly. So let's have a look. So you can see it's all over the place. So we wanted to always end up on line 76. Clearly we're not. Oh, and the other thing we didn't take into account is when we are too big, we just don't fit, but we'll worry about that later. So why did we fail so miserably, right? So we would like 76 to be our end. Of that, we take away the tag size. Oh, we have a lot of pluses here. We should really be subtracting all of these guys, I think. So 76 is where we want to end. Take away the tag size. Take away stars. Effectively, and we probably, if we were clever, we would do this in the right order. Tag size, title size, -1, stars. And then we could say tag space count is greater than 0. Then we want the tag space count, otherwise 1. Which really, ideally, we want this guy to do that, wouldn't we? So in fact, we probably want that to be greater than... No, greater than 0 is fine, I think. Well, anyway, let's not make this super perfect. Just needs to do the basics. Right, let's go back to our models and see how bad it looks. Okay, that's looking vaguely sensible. Not perfect, but vaguely sensible. Now what I want to see is what happens if... org was still not quite happy. So let's add 1. We need to make org not move this thing, because otherwise it's going to be absurdly annoying if every time we touch the headline... Okay, it's not moving it anymore. Yeah, org is not moving it anymore. Okay, so that's good. Now, and does it really make any sense? So configuration is an element. Model processing is an attribute. So let's just try to... okay, so that looks alright. That looks vaguely alright. What happens if I have an enumeration? Enumeration comes up as attributes, that's good. I mean, this is not necessarily the end-all be-all sort of state of the world. We might change this in the future, but we need to just get on and move to the next set of problems. So this is good enough. Alright, so let's just get rid of this then. What we'll say at this point in time probably something like org artifact to model. And should have two of these. That's the guy. So could say something like Codec add tags to elements and attributes in org mode documents. Actually, we're going to start saying just org documents because org mode is a bit annoying. Okay, and then we could just say we just regenerated all these. Of course, we should have run all tests. And whoa, we broke everything. Aha. Okay, so what we did, okay, that's fine. I think the reason why we broke everything is because we changed the behavior of keys, so that's fine. So what we'll do is this fine. This is not going to break the changes for the org mode model. So let's just say regenerate org models with tag support. This will not break anything. I don't know what that is, so get rid of it. And then what we need to do is need to just be careful. We can, for the chase and stuff, we could just say cosmetic tidy ups on the chase and transform, I think. That's also not a big thing. This, however, is going to break everything. So so I don't think model to org will cause any problems. So let's just say add org extension to reference resolution, and then this is just basically the work we did. So let's just say codec work on org to model transform. Okay, that's just that. Now the problem is going to be that all of the org stuff is going to break. So let's have a quick look at the tests. Not those tests, but the org tests. Right, so what we got now is we got a number of errors here. Let's have a look at what the errors are. So front key of 0. Okay, so when we change that regex, we broke something. So that's fine. Let's have a look at what we broke. So key of 0. Ah, okay, fine. So we did not take into account numbers. So that's all right. So we just go to parser, and in here we could say something like 0 to 9. let's just run that. So we don't really mind any numbers, any letters, or dots or underscores. And hopefully this will resolve our little issue. And that's good. And now we can say org allow underscores and dots in property drawer keys. That solved that particular problem. Okay, cool. Now that's really good. I mean, we really are already an hour and 15 into this. As you can see, this is very, very slow progress, so I'm afraid I'm not going to be able to record much of this, otherwise we're not going to get much work done. But nonetheless, you should get a flavor of the work that's coming. So what we've done now is we've managed to read the org model, and the org model is populating the properties. So what we're going to do next, which will be slightly more exciting, is we're going to now bind. I'm going to be a bit lazy here and actually just copy. What did we have here a second ago? Model to org artifact. Yeah, I'm just going to be lazy and copy these two guys here. In the real world, you would actually create some kind of common constants or something. But right. Okay. So now, if you can imagine, what's going to happen is, as you are reading an element, you're going to be saying, well, does the element have a tag? That's kind of the gist of it, really. So let's imagine that this guy is coming in, reads an element, reads a headline. So now what we've done as well is we basically say here that if the headline, we're going to be a little bit flexible here. We're going to allow headlines that don't have tags. So if the headline, not tags, not empty, then we can just return an empty list. If you see what I mean. Or if the headlines, so basically we only expect precisely one tag. So what we'll do is we will say something like for const auto by reference tag age.tags. So let's call this bool found. No, actually, to be fair, we want to know whether we're an element or whether we're an attribute. So we got like a tribal state. We need to know whether it's found an element, found an attribute, or didn't find anything. And also the other slight problem with this, which we didn't take into account, is if you do find an element, sorry, if you do find an attribute, we now need to, well, everything should be an attribute for starters, and we should retrieve not an element but a list of attributes. So actually this logic is not going to quite work, right? We need to sort of we need to have an expectation, really, when we're reading. We need to have an expectation of whether you should read elements or you should read attributes. So if you found an element, then the things below you either should all be elements or should all be attributes, in effect. There shouldn't be any mixing, matching, or anything like that. So if you read an element, then I suspect you then should say, yes, more the children, isn't it? Okay, right. Sorry, let me just put a break here because I think I'm going to have to do some thinking, and clearly talking while thinking is not my strong point. So what we're going to do next is going to be this. We just need to determine, so we're iterating to a 3. As we enter an element of that 3, we need to determine whether the current element is an element from the perspective of Codec or is an attribute. If it's an attribute, all the things that are going to be at the same level must be attributes. If it's an element, all of them must be elements. We should read all of those, and we should return. Now, when you're in the parent, you can't tell what the children are going to be, whether they're going to be elements or attributes. You need to go into the children. So the ideal scenario would be that given an element, or given a headline, you loop through the child headlines, and then on those child headlines you would apply some function. So that's what you're going to be using this function here. But because we've already gone into an hour and a half of this almost, and B, because this actually requires a bit of concentration, I'm going to do this work offline, and then I'm going to resume when we get to a point where we're closer to parsing the org document. Okay? Thanks so much for watching.